Welcome back, everybody. We're going to finish up our review of radicals and talk about multiplying, dividing, and rationalizing the denominator. When we're multiplying, it kind of works like the rules of fractions. It doesn't matter if they're the same radicals or not, as long as they're both square roots, they're both third roots, they're both fourth roots. And when we're finished, we always have to make sure that our answer is in simplest form. So if I have the square root of a times the square root of b, they're both the square root. So I'm allowed to say, okay, square root a times b is ab. In the middle, we have the square root of 3 times the square root of 21. Since they are both square roots, I can say 3 times 21 is 63. Well, this is a number, so we need to check. Can I simplify that? Well, I know that 6 times 3, or 63 is 3 times 21. 21 is 3 times 7. This is a second root, so we need pairs. So we have a pair of 3s that'll come out, a 7 that stays, and so this would reduce to 3 square root of 7. The square root of 50 times the square root of 72. Well, 50 times 72 is 3,600. 3,600, I could say, is 36 times 100. 36 is 6 times 6. 100 is 10 times 10. This is a square root or a second root, so I have a pair of 6s and a pair of 10s. So we're pulling everything out. We have 6 times 10, which is 60, and there's no square root left. So what happens if I have numbers or coefficients in front of the radicals? Well, it's no big deal. It's going to work the same way, just that we multiply like things. So a coefficient times a coefficient, 5 times 2 is 10. And then the square root times the square root, 6 times 10 is 60. We still have to make sure that our square root is as simple as we can possibly make it. So let's say 60 we know is 6 times 10. 6 is 3 times 2. 10 is 2 times 5. A square root or second root means I need a pair. So I have a pair of 2's and the 3 and 5 are stuck. The paired 2's comes out to multiply to the 10 in front. 2 times 10 is 20. 3 times 5 of the leftovers underneath is 15. And so that would simplify to 20 times the square root of 15. There's a 1 in front of the square root of 3. So 1 times 5 is 5. And then 3 times 2 is 6. Well, 6, again, is 3 times 2. I don't have any pairs to pull out. So 5 square root of 6 is simplest form. This last example, I have my coefficients of 3 and 4. 3 times 4 is 12. I have a square root and a square root, so 5 times 10 is 50. Well, 50 we know is 5 times 10. 10 is 5 times 2. So I have this pair of 5s with this 2 left over. The 5 comes out to multiply to the coefficient in front, which is 12. 5 times 12 is 60, with the 2 still under the square root. And that is simplest form. Dividing radicals. So dividing radicals, we can pull this out as 2 separate ones. So the square root of 25 is 5, and the square root of 9 is 3. I have 5/3. I can't divide that. I can't reduce it. So 5/3 is as good as that gets. 288 and 2. Well, if I rewrote that as just 1, because I'm allowed to do that, because they're both square roots, can I reduce? Can I actually divide 288 by 2? And the answer to that is yes. 288 divided by 2 is 144. The square root of 144. Well, that's a perfect square, which is 12. So we have the answer there of 12. This last one, 3/4. I can't divide that evenly. I can't reduce. So I'm going to separate it out just like we did that first one, to the square root of 3 over the square root of 4. The square root of 3. I can't take the square root. I can't break 3 down into anything that gives me pairs because it's just 3 times 1. So we leave that square root of 3. 4 is a perfect square, and the square root of 4 is 2. And so we would leave this as the square root of 3 over 2. But when we get to something where I have, for example, maybe we did the square root of 16 over the square root of 5. Well, we could take the square root of 16 and get 4, but I can't take the square root of 5, and I can't break 5 down, and so we have a square root of 5. Well, I'm not allowed to leave a radical in the bottom of a denominator. And the reasoning for that is because it doesn't matter if I eat square root of 5 out of 4 pieces. I know how to cut a pizza into 4 pieces, but I don't know how to cut a pizza into square root of 5 pieces because we don't know exactly what the square root of 5 is. And so we're going to do something called rationalizing the denominator. The first thing you're going to do is reduce whatever you can reduce out of the problem. Then we multiply the top and this is a fraction, so we're multiplying the top and the bottom by whatever that radical is in the denominator. And then we follow the multiplication rules that we had before to make sure that we have an answer and it's in reduced form. So let's try that. We have 3 over the square root of 5. Well, I definitely can't take the square root of 5. It's not a perfect square. I can't reduce it. So we'll start with the radical in the bottom is the square root of 5. I'm going to multiply by the square root of 5 over the square root of 5. Well, 3 and square root of 5, those are not like things, so I can't actually multiply them together, but we're going to make them sit next to each other. And on the bottom, the square root of 5 times the square root of 5, they're both square roots, so 5 times 5 is 25. Oh, well, we can reduce 25. The square root of 25 is 5. Now, we cannot reduce these two. Okay, the square root of 5 and the regular 5 on the bottom are not the same thing. So there is no reducing for that. And that makes our final answer 3 square root of 5 over 5. Square root of 4 over the square root of 2. Well, we can do the square root of 4. That is a perfect square. It's 2. Square root of 2 on the bottom, though, I can't take the square root of that. I can't reduce the 2's because one is a 2 and one is a square root. They're not the same thing. So our radical on the bottom is the square root of 2. I'm going to multiply by the square root of 2 over the square root of 2. 2 times the square root of 2, those are not like things, so we just make them sit next to each other. On the bottom, 2 times 2 is square root of 4, and the square root of 4 is 2. Remember, we can only simplify like things. These two are like things. The square root is not. Well, 2 over 2 reduces to 1s, and so we have the square root of 2 as a final answer. Square root of 27 over 5. Square root of 27, I want to say we can probably simplify that. We need pairs, so we have 9 times 3 and 3 times 3, and I can. I've got a pair of 3's with a 3 left over. So we will rewrite that square root of 27 as 3 square roots of 3. On the bottom, the square root of 5, nothing I can do with the square root of 5. So multiplying by the square root on the bottom, we have the square root of 5 times the square root of 5. This 3 on the outside is not like terms, so that's just going to sit down. These two are both radicals, so I'm allowed to multiply them together. 3 times 5 is 15. On the bottom, these are both radicals. I'm allowed to multiply those together. 5 times 5 is 25. And we know that the square root of 25 is 5. Remember that these are not like terms. One is a square root and one is not. So I cannot reduce those. And that makes our final answer just 3 square root of 15 over 5. Our last one here, square root of 5 over 8. Well, square root of 5, I couldn't reduce 5 over 8, so I'm going to separate them out. Square root of 5, 5 is a prime number. I can't pull it apart, do anything with it, so it's going to stay square root of 5. The 8 on the bottom, I know is 4 times 2. 4 is 2 times 2. I have a pair of 2's that I can pull out, and this 2 gets stuck under the radical. Now that I have simplified, remember, we only want to multiply by the radical in the bottom, and that's the square root of 2. So I'm going to multiply by the square root of 2 over the square root of 2. On the top, square root of 5 and square root of 2, they're both square roots, so I'm allowed to multiply them. 5 times 2 is 10. On the bottom, we have this 2, and then square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. Remember, this is multiplying. That's 2 times the square root. So we still have this 2. It's still times, and the square root of 4 is 2. 2 times 2 is 4. Can we reduce 10 as 5 times 2? But that's it. I don't have any pairs. And because the 10 has a square root around it, I'm not allowed to reduce the 10 and the 4. And so that is our final answer. Well, that's it, folks. Thanks for joining me for Radicals. Have a great rest of your day.